8.5 variation functions. Here are the objectives. Direct variation. You should write this down. Y varies directly as x if there's some non-zero constant k such that y is equal to k times x. And k is called the constant of variation. We also say that x and y are directly proportional to each other. Now, before we get into the examples, let me show you, there's one way to think about direct variation is if you take your y equals k times x, what will happen is, let's say that this is a y1 and this is an x1. And then you have two other variables, y2 and x2, and they are related by that same constant of variation. If you solve each equation for k, you're going to have y1 over x1 equals k, and you'll have y2 over x2 equals k, and then you can just substitute and set them equal to each other, and you can say y1 over x1 equals y2 over x2. And I'll talk more about this in class, about this being one way to solve direct variation problems. But the way I'm going to actually solve this is a little bit different than setting up that proportion that I did in the previous slide. So here's our first example. It says if y varies directly as x and y is equal to negative 15 when x is equal to 5, find y when x is equal to 3. Now it might seem a little strange to do all these steps, but I'll explain why later or maybe during class. What I'm going to do is I'm going to say, well, since it varies directly, we're going to have this relationship, y is equal to k times x. I'm going to use what I know, that when y is negative 15 and x is 5, to find my constant of variation. So I'm going to have negative 15 is equal to k times 5. Solving for k, we get negative 3. So that's my constant of variation. So now I have an equation that's actually y equals negative 3 times x. So y and x are actually related by this new equation that I've just created, because I just found the constant of variation. And then I'm just going to substitute 3 for x and solve for y. So y equals negative 3 times 3, y equals negative 9. And that's our answer. Here's your first video quiz question. Joint variation. You should write this down. Y varies jointly as x and z if there is some non-zero constant k, which is still called the constant of variation, such that y is equal to k times x times z. Notice that y is varying jointly as x and z, and your equation is k times x and z. So joint variation is related to direct variation in that we have a multiplication operation going on here. I also want to point out that just like with direct variation, there's another way to think about this. If we have y1 is equal to k times x1 times z1, and then we have another relationship that's the same, y2 equals k times x2 times z2, and we were to solve each of these equations for k, we'll have y1 over x1 z1 is equal to k, and then we'll also have y2 divided by x2 z2 is equal to k. So one approach to solving this problem could just be to set these equal to each other and say y1 over x1 z1 is equal to y2 over x2 z2. And I'll address this more later and certainly during class. If I forget, remind me. All right, here's an example. So once again, I'm going to start out with, it says that y varies jointly as x and z. So I'm going to set up my equation. I know they're going to relate like so. Y equals k times x times z. And I want to find y when x is 10 and z is 5. If I know that, so this second half of the sentence is what I'm going to use to find my constant of variation. So I'm going to substitute 12 for y equals k times x will be 3 and z will be 8. So that's actually 12 equals k times 24, and divide by 24, so k equals 1/2. So now I know that my actual equation that relates these variables is y equals 1/2 times x times z. So now I'm going to substitute, it says find y when x is 10 and z is 5. So I'm going to have y equals 1/2 times 10 times 5, so that's going to be 1/2 times 50, which is 25. And that's my answer. Here's your second video quiz question. Inverse variation. You should write this down. Y varies inversely as x if there's some non-zero constant k, again called the constant of variation, such that y is equal to k divided by x. Notice here that the operation that we have going on is division, which makes inverse variation different than direct and joint variation, which both is multiplication. But again, you can approach these problems a little bit differently. Let's say you have y1 is equal to k divided by x1, and separately you have y2 is equal to k divided by x2. If you solve each of these for k, you're going to have y1 times x1 is equal to k, and over here you'll have y2 times x2 is equal to k. And setting those equal to each other, you will have, I'm just going to switch the x's and y's around, put them in alphabetical order. x1 times y1 is equal to x2 times y2. So this would be one way that you could solve inverse variation problems, but I'm going to stick with the original definition. And so here is an example. Oh, the slide looks a little different here. Here's an example using inverse variation. So r varies inversely as t. So I'm going to say r is equal to k divided by t. And it says that r equals -6 when t equals 2. So I'm going to use that information to find my constant of variation. So -6 is equal to k divided by 2. So -12 is equal to k. And they're asking us to find r when t is equal to -7. So my new equation is actually r is equal to -12 divided by t. And so r is going to be -12 divided by -7. And so we just get 12/7 is r. Here's your third video quiz question. And now here is kind of a summary of what I was saying about the two different approaches. The one on the left, these are the original definitions of direct variation, joint variation, and inverse variation. And so this is the approach that I generally take to solve these types of problems. Other teachers and other sources might show you this technique over here on the right-hand side. Like I was saying, for direct variation, you can just set up a proportion of your two variables. And it doesn't matter if you have y over x and x over y, as long as you're consistent. And for joint variation, you're going to have your y over your xz and set up another proportion. And for inverse variation, you'll just say x times y is equal to x times y. So your x1, y1 equals x2, y2. And I'm not going to show you any of those in that technique in this video, but we will talk about it in class. Okay, this is our last example. So here we're kind of putting it all together. It says, suppose f varies directly as g and f varies inversely as h. So for our equation, we're going to say f is equal to, it's going to vary directly as g, so we have to do k times g, and it varies inversely as h, so inverse implies that division. So that's how I'm going to set up my formula, my equation. F is equal to k times g divided by h. And we want to find g when f is equal to 6 and h is equal to -5 if we know that this relationship is true. So again, the second half of the sentence is what we're going to use to find our constant of variation. So f is 5, k is what we're looking for, g is 18, and h is 3. So when I solve, that's 15 is equal to 18k, divide by 18, and they're both divisible by 3, so that's going to be 5 over 6 is equal to k. So now I know that my relationship is actually, I'm going to write it up here, f equals 5/6 times g divided by h. So now let's go what we're looking for. It says to find g when f is 6 and h is -5. So I'm just going to substitute. I'm going to have 6 as f, 5/6 times g, which is what I'm looking for, divided by h, which is -5. So I'm going to multiply both sides by -5. So I now have -30 is equal to 5/6 times g. And the quickest way to isolate the g there would be to multiply both sides by 6/5, because that's going to cancel out the 5/6 times 6/5, of course, is just 1. And to multiply 6/5 times -30, you can multiply across the top, multiply across the bottom, and that's going to end up giving you -36 is equal to g. This is your fourth video quiz question.